Hello everyone, so today we're going to learn how to solve this question. We will do this question by induction, and let's see how we could do that, okay? One moment. Okay, so first we have to do this by induction, so prove by induction. Okay, so for induction we have to check the base case, which is n is equal to 1. So we're going to plug in n is equal to 1 here. Okay. We're not going to care about this part here, right? So ignore this part and just plug it in here. Okay. Plug it in here and plug it in here. This is just to show that the left hand side is equal to the right hand side, right? So if you do that, then you end up getting what? You end up getting 1 squared plus 1 times n factorial times 1 factorial is equal to 1 times 1 plus 1. That is 1 plus 1 equals 1 plus 1. That is 2 is equal to 2. So we're good for step 1. Step 2 is to do the inductive hypothesis. So the inductive hypothesis, we're going to assume that S of n, the statement n, that's what S of n means, is true for some positive integer n. So we're going to assume that. And step 3 would be to using inductive hypothesis from step 2, we are going to prove that we have to prove that S of n plus 1 is true. Okay? That is S of n implies S of n plus 1. Okay? All right. So how do we do that? Now, usually what happens is that these kind of questions come up in something like in summation form. Okay? So these kind of questions come up in summation form. And yeah, so like what do you do then? Well, when it comes up in summation form, always try to expand it. Expanding should be your first step, okay? Everything else should be your next step, all right? But expanding should be your first step, okay? So this is already in expanded form, so we don't have to expand anymore. But if it's given to you in summation form, do write it in this form, in this expanded form, okay? All right, so once you put it into expanded form, then you can, move on with step 3, right? So, okay, so step 3 is what? S of n plus 1. We know this part. We know S of n, right? We know that. That's just what? S of n is just this part here, right? So now we have to figure out S of n plus 1. So what is S of n plus 1? So we're just going to basically plug it in here. So wherever you see n, replace that with n plus 1, okay? Cool. So, well, kind of lazy, so I'm not going to write the entire thing down. I'm just going to copy and paste it here. I'm just going to change some words. Okay, let's try it again. Copy. Oh, okay. Cool. So we're gonna make some changes. So we're gonna put n+1, right? So we're gonna put n+1. So it's going to be n+1 squared plus 1 times n+1 times n+1 what? Times n+1 factorial equals n+1 times n+1 plus 1, right? So I just replaced n+1 here, 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 and here. Again, that's how I got these values, right? Cool. Okay, so once we have that, so this is S of n. I'm going to write that down, S of n plus 1. Yeah, then we're just like basically, you know, copy this portion. But what's very unique here is that I'm gonna move this around a bit. Okay, so what's very unique here is that this entire statement of S of n comes within, it comes under this. That's very unique, right? Okay. I think I have to put a plus on here. Plus, right? Okay, so I just basically wrote down S of n plus 1. Okay. Okay. Cool. Now check out something really quick. So we know what this part is, right? We know what this part is. It's not correct. We know what this part is. This part is just, I'm going to highlight it. It's just this part, right? Oh, sorry. No, it's thicker, but I need something bigger. It's just this part here that's highlighted with the yellow color, right? Okay. And what is that equal? That's equal to n times n plus 1, right? Based on here, it's equal to n times n plus 1. So we could say that, hey, this is just n times n plus 1, right? And then rewrite it, right? So we got what? N times n plus 1 plus n square, n plus 1 squared plus 1 times n plus 1 factorial is equal to n plus 1 n plus 2, right? Am I missing something? Hopefully not. Oh yeah, I was missing factorial, sorry, in the question, and I was missing factorial here. Okay, good. Yeah, so now how can we go about? Well, let's see. So I have to put factorial here as well, because that's where I kind of messed it up a little bit. Okay, factorial, and then the plus sign. N times n plus 1 factorial. Okay, cool. Good. So we have everything fixed up. So right after that, what you have to do is you have to factor n+1 factorial, n+1 factorial. Okay, so factor that out, you end up getting n+1 factorial. I'm going to use big brackets, n+1 squared plus 1, okay, equals n+1 times n+1, n plus not 1, actually, yeah, it should be n+2, right? Yeah. n+2 times n+1 factorial. So I just basically expanded this here, right? I mean, this just becomes what? n+2 times n+1 times n minus 1, blah, 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 right? So all the way up to like 3, 2, 1, right? So yeah, so that's how I broke it down. So that's something that you have to kind of notice, right? That you can break this down and do something with it. So once you do that, you end up getting this n+1 factorial. Now easily you can just divide it up. Easily you can just divide n+1 factorial, divide n+1 factorial. That just becomes 1, right? So once you have that ready, what do you do next? You just do, you know, like n+1 squared plus 1, which is equal to n+1 n+2. Now you just FOIL it. Once you FOIL it on the right hand side, you end up getting n squared plus 2n plus n plus 2, which is n squared plus 3n plus 2, right? You just FOIL this, right? Okay, and then on the left hand side, which is on the left side, you end up getting n plus 1 times n plus 1 plus 1. That just gives you n plus n squared plus 2n plus 1 plus 1. That just gives you n squared plus 3n plus 2. Therefore, we have proven by induction that the left hand side is equal to the right hand side, and we're done with the proof, right? So this is how you would do something like this, right? This is one of those, I wouldn't say super easy ones, but definitely on the easier side of the induction. If you have done induction, you know how hard it can get. There are weak inductions, strong inductions, etc. But this is one of the simpler versions. But if you don't understand this, don't worry about it too much. Just, you know, do a little more practice. Try to understand the steps, you know, and then you should be okay. All right. So with that said, I'll see y'all soon, and thanks for watching. Take care.